Um, yeah, so Blogcast number two, it's titled The Future of Kubernetes. And we got James with us and me,
Hello.
but we'll go first. James, what's maybe tell us a bit about yourself, what you do at Manifold and stuff?
Okay. I'm James. I am the technical lead at Manifold. Uh, right now, that means a lot of time uh, developing some applications on top of Kubernetes using the Kubernetes APIs. It also means writing a lot of documents and reviewing pull requests, and doing ops work too when I have the chance. And yeah, hopefully coding more often than not, but usually not.
Cool. Um, and just as an interest question for the audience, how long you've been working at Kubernetes so far?
Uh, since like August of last year, almost a year, I guess. I've been, playing around with it. Not too long in the grand scheme of things, really. But in the life of Kubernetes, things move fast and things change quickly. So,
Cool.
you can jump in and sort of get, as long as you pay attention, you can catch up pretty fast.
Yeah, definitely. I think that's also like the core's been stable for quite a bit as well. I think that's a pretty great feature about Kubernetes. There's not much changing anymore. Um, so yeah, I guess it's a little bit the same with Go as well. And once you have that API, you can be pretty confident that you can go to the next version without much issues.
Yeah. You want
Um,
to tell us about yourself, Yelmer, or did you do that in the
I did it in the last one, but
first?
I can do it
Okay.
over again. So I'm a tech lead at Manifold, more specifically for the OX squad, which is the Operations Experience Squad, which focuses on Kubernetes and other operations integrations, stuff like that. Another one is Terraform, for example. And I've been playing with Kubernetes for roughly the same time. I guess we started around the same time when we started discussing these things. Um, so yeah, that's my very brief introduction to all of this.
Awesome.
Um, so yeah, this podcast was like aimed to like speak about the future of Kubernetes, but we came up with some questions that also speak about the history and like how we did things at Manifold. Um, and yeah, we'll just have like a little chat about a few topics and just go over things and see how it goes from there.
Yeah.
Um, so the first one that's on the list is Manifold migrated. I think it was January from our legacy system on AWS to a Kubernetes solution. And we got a few questions around that. And I think the first one is actually that came from me. And like, I'm very interested in that. Would you have done something differently? Like looking back at all the stuff we've done, is there anything you would have changed in that perspective?
Hmm. So our actual cutover from the legacy infrastructure to Kubernetes was really fantastic. You can read more about that on our blog in a post that Yelmer wrote. But we were able to migrate without any downtime, sort of run things concurrently and send some traffic to the new infrastructure, and then migrate everything over. So that part was fantastic. Like I wouldn't change anything about that at all. Um, and we were kind of hamstrung in our use of RDS and uh, whatever the encryption, Amazon encryption thing. Um, so moving providers was more difficult. Uh, uh, at the time, maybe I would have pushed our AWS account manager a little more aggressively for access to EKS.
Yeah,
uh,
I think we released and like 2 weeks later they announced it um, that it was becoming like privately available. Um,
mm,
but yeah, I think yeah, the migration was actually pretty successful. I guess
yeah,
we didn't have any downtime. And so far, we've only had one issue, which was like twofold, uh, which was like a memory leak, and then also something of an issue with cops, uh,
Mm.
of not pinning down versions of images. So I think, yeah, in general, that migration was pretty smooth. I don't know if, yeah, if you've got more to add on that, or
We could have. I'm just thinking about it now. We went from a system that was basically a single container per VM to higher density of sort of however many containers would fit. We could have taken an intermediate step and then increase the container density on some of our hosts first, and also looked at defining sort of some resource constraints, even just in Docker before moving over. Uh, yeah, that there's sort of just things to prepare us for the increased density. That said, it's not like it was that large of a problem. It was only sort of one service that was having issues with its aggressive consumption of memory,
yeah, I think,
or a leak.
yeah, I think that the migration itself didn't really lead to that, because I think we were already aware of that memory leak before we actually moved to Kubernetes as well. We just
Yeah,
chose to not really do much about it until it actually hit us.
yeah,
Um, so yeah, I think, yeah, the server density is actually quite interesting. If you looked at our graphs from or metrics from AWS, we chopped down like so many servers, which is
yeah,
pretty interesting. Obviously, our servers are bigger now, um,
yeah.
but yeah, we cut down on a lot of overhead, which also led to like obviously the speed up of deployments, and that's, I
Mm,
think that's one of the main benefits that we got out of that.
yeah. There's other things too. Like when you increase instance sizes, if you stay within the same class, you sort of double your resources and you double the cost. So it's pretty fair trade off. But once you get to some level and you jump to the next like instance size in a class, then you go from sort of normal networking into enhanced networking, and then you've got actually a better network connection. Or you go from uh, like effectively it works like a single interface that goes to your networking as well as like your block storage. Um, and then you switch to having a dedicated interface for block storage. So there's sort of like add-on benefits to increasing instance size that are, you know, pretty good. So while before it was like we didn't want to have massive instances for a single container, now we could sort of go up to wherever we want in that listing of instance sizes, get the extra goodness of networking, and not sort of waste the compute and memory resources.
Yeah, definitely. Yeah, actually, I hadn't thought about that yet, because we get that
Mm.
obviously. I think we started out on a low networking system, and now we're
Yeah.
on a medium, I think. I don't know how they name it, but yeah, that's definitely something that you move towards, which is
Mm.
pretty interesting. What I found really interesting actually about the whole migration is the monitoring, and how easy Datadog makes it, because they
Yeah.
have like this whole pre-built um, dashboard for Kubernetes, which is actually pretty cool. You just install their daemon set in the cluster, and it just appears in your account. That's pretty good.
Yeah. Yeah. It'll be interesting to see how that, since we're just starting to bring in Prometheus a bit, to see how we can connect up our Prometheus metrics with Datadog. I haven't even looked at it. I'm sure they have an integration.
Actually, like I looked into it a little bit, because we are running statsd, so I looked at, can we
Yeah.
actually use statsd to put that in Prometheus and stuff like that. And there are
Yeah.
some connectors that do it, and there I did see something mentioning Datadog as integration for that, so we can definitely
Mm.
like do something with that. And yeah, it would be like, instead of what we do now with statsd of like pulling it out of the application, if we have all our proxies in place and stuff like that, that would be quite interesting to just use that instead of the custom bits. Um,
Yeah.
so yeah, that's definitely something to look forward for. Um,
Like the migration never ends, really. It's always
Yeah, and I think that's like
yeah.
a big thing. I mentioned that in the blog post as well. A lot of people, or not in the blog post, I can actually mention it in the previous blogcast. Um, a lot of people don't realize it. They go from their current infrastructure and what they currently have, and then they see Kubernetes, and then they expect that they have to like go full on with everything in Kubernetes, and they have to have everything in place to have like the perfect solution. But what we did as well, like we rolled out gradually.
Mm,
Like we didn't start with resource limits, for example. We just added that sporadically on. And the first thing we did is just make sure that we have our infrastructure mimicked from what we had before. And even by mimicking it, it already had a lot of improvements. Like we had automatically like the DNS setup and the SSL certificates that we didn't really
yeah.
have to think about anymore. Um, so yeah, I think a lot of people don't seem to realize that you can like you don't need to start out with everything in place yet. If you can just
Mm,
mimic what you have, it's good enough to start with. Um, so yeah, I think that was pretty interesting to see as well.
yeah, for sure.
Um, we touched on it a little bit earlier, but how excited are you about Amazon EKS? And like, do you think we should migrate or like get that prioritized at one point?
I mean, we're done now. We already have our own control plane, so no, I think that there's having someone else handle this. You know, comparing all of these sort of the managed control planes from the big cloud providers. There's some differences and there are some limitations on what you can do. Like they sort of dictate the number of um, nodes that you can have in your cluster, like sort of minimum amounts and definitely the size. So you are required to have sort of some minimum instance size and a reduced selection of instance types. But if it fits, then why wouldn't we? That means that we have to run and take care of three less systems, right? And usually that means you also don't have to pay for them. So reduction is cost is good. Uh, and it may be different if this was some other kind of orchestration system. Um, like if we were looking at Mesos and Marathon here, and you had your control plane for a Mesos was managed, and you weren't able to add in um, Chronos to do periodic jobs or something like that, then um, that wouldn't be great, because you want to be able to actually use it how you want to use it. But as far as I can tell, you've got your you got etcd and API server and the controller manager and scheduler going in the sort of managed control plane. But if you want to add in extra API servers for API server aggregation or just additional controllers that are listening, you can do that no problem, and you're able to quite easily add on additional functionality into any of the managed providers. So it seems like there's, um, as long as the pricing is right for the instances, there's sort of all the benefits and like no real downsides.
Yeah, definitely.
Yeah.
Actually, I haven't looked at it. Is the pricing any different for EKS for the nodes than it is for regular nodes, or
The prices are like usually the same. Yeah, and last I was able to see the pricing for it, I think, like in February. But for your nodes, you pay the same price. You usually don't
yeah?
pay for the control plane, but they limit the instance classes that you can use.
Okay,
So even though the nodes that we use now are, say, I think they're like, medium level M4s. Like, actually, they might be M4 large. So we might fit into that, but like, you
yeah,
wouldn't be able to use the small node instances, even though they could quite happily run Kubernetes, run the kubelet.
yeah. They just limit it, and that kind of like means that you can't really do like very small clusters, I guess. Like you
Yeah,
would be able
exactly.
to do with cops and stuff like that. Well, you mentioned earlier, like with the whole extra controllers and stuff like that is
Yeah.
obviously an interesting point, and it also brings us to like another question on the list. I don't know if it
Mm.
was that why you mentioned that, but the whole custom resources, and personally, I think that's obviously one of Kubernetes the most strong, yeah, the best things about Kubernetes so far. Um, for me personally, because I've been working with custom resources since well January now as well,
Yeah.
and that's the only thing I've been doing. Um, and it is quite interesting. And the capabilities that you have with it are pretty amazing. And I know you wrote a blog post about that as well, like what's still missing and stuff like that. So maybe like if we can go over that quickly in this one as well. I can bring it
Yeah.
up if you want.
Uh, good. Um, yeah, custom resources and custom resource definitions are like it's something that on the surface is like I remember when I first looked at them, I was like, well, why do you want this? Like, why would a REST API let you define a new type of object within that API? And even when you look at the documentation for it, it's really just like, hey, I'm adding this new type to the API. End of story. What do you do with it, right? Um, but it turns out that what you do with it is what you can do with any other resource in the system. So you can define any logic you want that sort of listens for the creation and modification and deletion of these custom resources. And so that's where we do things like have one that is a composite of other resources, and you can define one thing that's tiny and have it sort of spit out a deployment and and a matching service and network policies and everything else, which is can be pretty powerful. But you can also use it to do things like add configuration on how you might modify other resources in the system. Like policies for the horizontal pod autoscaler are their own resources, right? I don't think they're custom resources, but they could be. Like,
I don't think they're custom because I think
yeah,
the autoscaler is built in, so it
yeah,
might be a built-in thing. Yeah, but yeah, I think that's all pretty interesting. Like especially like the modification as well. Like
yeah,
we've seen and we're experimenting what you can do with all of that. And yeah, just like the fact that you can have this amazing tool that you can actually ship to um, different different cloud providers and stuff like that, and then actually build your own custom logic or like business logic on top of that, I found very powerful.
yeah,
Um, and yeah, like we've seen some great implementations. Like the one I'm most excited about is like the whole Let's Encrypt cert manager from Jetstack. The work they've been doing in that I find pretty amazing because like it just enables so much people to just they don't have to think about it, and they can get SSL certificates in their cluster, which is pretty cool. Um,
yeah.
is there anything that you're excited about, like within the whole CRD scope, and that you're thinking like, oh, this is going to be cool?
So the big thing that I'm most excited about is, and it's also still the largest piece that's missing, is an upgrade path for multiple versions. So in Kubernetes, there's a very strong sort of um, backwards and forwards compatibility guarantee for resources. So you can have you can sort of ask for the V1 beta 1 version of a deployment, and it might be apps V1 in your cluster, and you'll still be able to read it right now. So it's nice. There's sort of mechanisms for translating between versions. So your any clients consuming things, which would be like kube control as well as other controllers in the system, don't need to like all be updated in one go. It also means you can make containers and have them ship them around and not worry about necessarily worry about the API that's on the cluster it's going in. So having that upgrade mechanism or sort of translation layer for CRDs is somewhat long-standing, um, but also when it's done, it'll be really awesome. Then you kind of don't have to worry about like, oh, what if I made a mistake in how I defined this CRD? Well, doesn't matter. You can put in the upgrade path later.
Yeah, that's something I noticed like with the work we're doing now is like, well, if we mess up the definition now, then we gotta like change it all again.
Yeah,
Which for us isn't really that big of a deal. Like the
no,
new things that we're making are all just running in development and stuff like that. So it's like not that critical. If we need to wipe it and like redo it, it's fine. But yeah, that update path for like critical bits is yeah, would be quite cool.
so with that, and there's already some validation with like Open API schema, and then if you need complicated validation logic, you can use admission webhooks. Uh, it's there's oh, and then there's also something new that's like is still sort of on the development branch, is a way to annotate fields in a CRD as things that should be shown in the
Oh
like
yeah,
when you do a kubectl list. So that's pretty awesome. Like there's the difference between a CRD and a sort of intrinsic resource is, it's shrinking like all the time, and you could really see a point where many of the resources that are defined like within the Kubernetes core just become, implemented as CRDs instead. So that you could get to the point where the only actual resource defined in Kubernetes is the custom resource definition, and then everything else is just done as custom resources.
then it would actually be possible to say I'm just gonna deploy a cluster that only knows about pods and nothing else, and then
Hmm.
people can only deploy pods and nothing else anymore. Um,
Yeah, it might be dangerous, but it's
oh yeah,
conceptually it's really
definitely.
neat. Yeah.
Yeah, like I don't remember what exact um, I think it might have been the autoscaler that they were thinking about moving it into custom resource. I don't remember. I don't want to like definitely say that was the one. But I was reading some documentation and they were considering it, moving one of the core bits already to a custom resource, or one of the alpha or extension parts, and moving that to a custom resource. And I think definitely makes sense. Like if you have something that gets developed by well the core maintainers, and then they keep maintaining that, and then they see, oh well, this custom resource bit needs some adjusting. That will make it easier for everyone else as well.
Yeah.
And I'm very excited about what you mentioned as well, that the listing bit where you can actually show values. Yeah, that's going to be pretty dope. So like to um, see some more stated information on deployments, for example.
Yeah. Yeah. It's really cool to have a way to sort of um, influence the kubectl, and without having to actually modify it itself. So you don't have to worry about people installing plugins or something on every machine they might use.
Yeah, definitely.
Yeah.
Um, Sorry, I'm just blanking out a bit. Um,
Yeah.
I see that you've also wrote down the API server aggregation for external APIs. Don't know if you want to go into
Yeah.
that a little bit.
Yeah. Like super related, right? The two paths for adding new resources into a cluster is either to use a custom resource definition, which is stored within the API, so the main API server, or the API server can also act as like a proxy to other API servers, and with their their resources under like an API group. So like everything namespaced. Um, and I always looked at this and thought, wow, okay, so now I've got to build a complete API server infrastructure with, since you're probably duplicating Kubernetes code, you'd have your own etcd cluster behind it. You'd kind of have to depend on having one because you may not have access to the control plane, like in the case of EKS. Um, so then you got to worry about uh, what you want your availability guarantees to be, and durability of data and everything. It sounded like a lot of work, but just looking at the metric server recently, right, which is a
Yeah.
uh, very small. little server that only handles core metrics for pods and nodes, um, and it's just done in memory. So, and it just sort of delegates to essentially like scraping from the kubelets and their sort of their metrics information. And if you have something that is sort of on demand for viewing this data, using an API server that's then aggregated into the main API server is kind of neat for that. So you could see using that for something like I don't know, just if you wanted to have on-call information in your cluster for whatever reason, um, you could have an API server that is aggregated into the core one, and anytime someone asks for some of these like on-call resources, it could actually go out and talk to PagerDuty and say who's currently in the schedule, and then return the resources for that. Likewise, you could also have a CRD that defines that, and then have a controller that periodically synchronizes it in. But there's some interesting use cases, I think, for just having like sort of a stateless or a sort of non-persistent API server that's aggregated.
Yeah, definitely.
Yeah.
Um, so I don't know. Is that like something towards a virtual kubelet, or is that a totally different topic? Because I got a feeling it might be related, but I'm not sure.
No, not really.
Okay, never mind then.
Yeah,
Well, we can go into
it
the
was
virtual kubelet if you want, because I have no idea what it is, like what I mentioned
sure.
before. Um,
Yeah. So if you look at like EKS or AKS or GKE or any other TLA or K8S, um, you've got these you've got these managed systems that the control plane is, you can kind of assume what it will be. It's probably stock Kubernetes, and it's probably running on 3 different hosts, right? And they've probably spread them across different availability zones. Um, but it doesn't have to be that way. What matters is the API that's exposed to you for your control plane. You want to be able to register. You want to be able to like list objects and watch changes. Um, and you expect that the kubelets you're running on your virtual machines will be able to connect and figure out what's been scheduled for them, and and go like that. And you expect some parts of the control plane may poke into the kubelets themselves and see what's going on. Uh, but that could be implemented as like, let's say there's 3 super beefy machines that are actually appear to be sort of separated per user, but there's actually some kind of multi-tenancy going on that one of the cloud providers has written themselves. That's not like in upstream Kubernetes, but they're using it to sort of increase the density that they have for users of it, instead of having to spin up 3 instances for every customer. So you've effectively got a virtual control plane, or at least in most of these managed cases, it's in like an opaque control plane. You're not really sure what's in there.
yeah. Okay. Interesting.
So if you tie to that a virtual kubelet, um, in that case, you're probably setting it up so you kind of know what's going on behind the scenes. But this is like a process that runs somewhere and connects to your control plane and says, "Hey, I'm a kubelet. I'm a node here. Um, and I've got infinite resources. So just hand me, schedule stuff to me. Um, and I'm probably always going to be able to run it." And then it sees when pods are scheduled to it. And there's just like for writing one of these, there's some ridiculous number of like a small number of API like endpoints you have to implement, like 5 or less or something. Um, and you just need to say like, all right, so I've got a pod here now. I'll go and actually execute it, and then there's some methods for like shutting it down or getting status on it. But the implementation of this might have it go and run on like, I think sort of the 2 starting ones were like Hyper Hyper SH and Azure's like sort of virtual container thing. I always forget the name of it. Um, but basically, you can just run containers in this sort of big, amorphous blob of compute resources. And so hooking up a virtual kubelet into Kubernetes means that you don't really know where or what your control plane is, but you have an API that you can access. And then, you don't really know what or where your nodes are. You've just got one big pool of resources available. So you put this together and you've just got a like an API for running whatever you want, and that API matches the Kubernetes API. But
Yeah,
the implementation underneath is sort of doesn't matter and could be infinitely scalable. Uh, so it's really neat. It's also in some cases like you probably want to actually know where things are running so that you can have good data locality. But maybe you don't care. It's
yeah,
kind of cool.
it sounds very interesting for like on-demand things or like serverless and stuff like that.
Mm-hmm.
Um, I don't know, like may I thought that Amazon had something similar to Lambda, but more for containers.
Yeah,
Got a name. It would be
Far
like,
Fargate.
yeah, that one.
Yeah,
Sounds pretty interesting for things like that as well. Um, yeah,
yeah.
I'll definitely have to look further in it. Um, is there like, yeah, is there anything else you want to talk about?
Um, I would like to hear your thoughts on Federation, Yelmer.
Oh, do you? So yeah, I think Federation is actually quite an interesting one. Yeah, like it's been tried before. Like they had this
Mm,
whole there was this whole topic about Federation I think a year and a half ago um that I started noticing things about Federation. It actually got like really like these things really interest me. Like how do you get things from one cluster to another, or like how do you go from one cloud provider to another, right? I think that's the dream, and especially what we do at Manifold as well, like the marketplace that we run, is
yeah.
become cloud independent. And at the moment, if you stuck with if you host yourself at Amazon, you're still kind of in the Amazon environment. Obviously, if you have Kubernetes, well, you take that whole infrastructure away, right? You don't have that. You don't have to think about EC2 instances anymore at the Kubernetes level. You still have to think about it when you set up Kubernetes. But what if you can all take that away as well and actually just move over from one cloud to the other? For example, like yeah, if there's an outage on Amazon, I think we saw an issue like a year and a half ago as well. Like Amazon had issues with S3, and a lot of people had issues with that.
Mm,
But what if you take everything that you have then and just run it on another cloud and you don't have issues? And that just takes high availability, like from multi-region to like multi-provider, basically, which is pretty interesting. Um, so yeah, I'm very interested in that. And yeah, it's just there's so much work to do it. And
mm,
like even for us, when we did the migration, we started looking at moving to another provider as well. And then well, we started noticing, I think our biggest blocker was basically a database. And also related to that is or KMS, or encryption layer.
yeah.
And how can we tackle that? And I think we did a good job with how we set up our encryption layers and stuff like that, but we still have to like scale that across different providers. And I think
Mm,
for people, that's going to be the biggest blocker. Um, Plus, how do you do like load balancing across different providers as well, right? I know that Google, they recently announced an interesting project as well where they easily load that across multiple regions. I forgot what it was called. I'll try and find it to link it in the post. But yeah, it's like things like that. How will you do that across Azure, AWS, or DigitalOcean, stuff like that.
Yeah.
Yeah, I think that will be interesting to see how this gets solved. Um, so yeah.
I saw I believe it was a talk um, that was, I mean, it doesn't strictly handle like multi-cluster or federation, but their recommendations for doing multi-cloud was to run your control plane in one cloud and actually connect nodes from another cloud, like another cloud provider, completely different region, to that control plane. And then you could set up taints on your nodes to actually say like this one is on this provider and it's in this region. Uh, it's certainly an interesting approach, but and if you lose connection to the control plane, these nodes are going to just keep going, doing what they were doing and running their workloads. But it does still feel a little frightening.
Yeah,
I don't
definitely.
know. Yeah.
Yeah, it's that thing of like, well, I mean, high availability is like just like how much effort do you want to put into it,
Yep.
and I think for most people you don't need to put that much effort into it. I think a lot of people overestimate or like yeah overestimate how important it is to like have like X amount of nines.
Mm.
Um, but if you are at that scale and if you have to reach that, then it does feel scary. Of like, oh, we'll just put it like that control plane in one region or like
Oh.
one provider, and then just hope that everything else is fine. Yeah, that still sounds scary, but it's a way forward, I guess. And it's somewhere to start.
Mhm. I wonder if you could like sort of reparent nodes. That would be interesting. So you could start by just bringing up nodes in a new provider, and then later on bring in their own control plane and just sort of
So
adopt the nodes.
yeah, basically move the masters from one control like one provider to another, basically,
Well,
and just
still keep like two control planes. Just say that you had control plane here with some nodes and the nodes over here, and you brought up a new control plane and put the nodes under that
oh
one.
yeah, like that. Huh. Interesting.
Probably a lot of work for very little benefit.
Yeah, well, that's again like that's the question. I think you mentioned it in the beginning as well. You have to think about like all these things, and if you want to go to this scale, it just becomes harder and harder to solve.
Yeah,
So yeah, oh, it's all very exciting though, and I think we'll see a lot more exciting stuff in the future. I don't
yeah.
know if there was anything else that you wanted um, to
I don't
touch
think
on.
so.
I think we covered most of what we wanted to talk about anyway.
Yeah,
Okay, cool. Well, thank you for your time, and thanks for the people listening and reading the blog
yeah,
post as well. Um, and hopefully we can do this more.
absolutely.
All right.
All right.
Bye.
Bye, Yammer.